a rational function can have only one problem. Never with a numerator. Only with the denominator. So what could the problem be here? If I plug in 3, I get 1 in the denominator, and that cannot be a problem.
Right.
Because I can divide by 1. The only situation in which I cannot divide is when I divide by, or try to, by
2.
By 0. In other words,
0.
when x is 2. Correct. Very good. Excellent. Let's factor the numerator. Can anyone give us the factored form of the numerator? Anyone?
X plus.
Careful.
Oh, I didn't see that was the negative. X minus 3 and x minus 1.
Excellent. So the reason why we factor the numerator is because we need the x-intercepts. So x minus 3 times x minus 1 over x minus 2 equals 0. When is a fraction 0?
When it's undefined. No.
It's undefined when the denominator is 0. But when is the fraction 0?
When the numerator is 0.
Very good. So x minus 3 times x minus 1 equals 0. So we have 2 options for x. And the options are
3 and 1.
very good. Thank you very much. Awesome. So 1, 0, 3, 0. Great job. Obviously, x equals 2 is a vertical asymptote, so I need the signs of the infinities. We're going to use a number on the left and a number on the right. The closest we can think of. Like 1.9. So let's plug in 1.9 everywhere. When I plug in 1.9 here, what is the sign? Just the sign.
Negative.
Perfect. With 1.9 here, what is the sign?
Negative.
1.9 minus 1.
Positive.
Very good. With this one, 1.9 minus 2.
Negative.
Very good. Negative over negative, what is the sign?
Positive.
Excellent. Great job. Now let's plug in 2.1. When I plug in 2.1 here, what sign do I get?
Negative.
Excellent. With 2.1 minus 1, what do I get?
Positive.
Excellent. With 2.1 minus 2, what do I get?
Positive. Positive.
Excellent. There is only one negative, so this must be negative. Okay. Final step. Oh, not final. I have to plug in 0 first. Okay. So 0, 0, 0, 3 over negative 2. So f of 0 is negative 3/2. Okay. So this is our final step. And we know that it's type 3. Since it's type 3, we'll not have a horizontal asymptote, but we'll have a slant asymptote. How do I determine the slant asymptote? Is I divide the numerator by the denominator using long division. So x squared minus 4x plus 3 gets divided by x minus 2. This is only for determining the slant asymptote. That's why we studied 3.3 for 3.5. X times what is x squared?
X.
Very good. We go back and distribute. X times x is x squared, but I have to change the sign. X times negative 2 is negative 2x, but I have to change the sign. Perform the operations I see. Negative 2x, and I bring down the next in line. Like we did in the previous section. X times what is negative 2x?
Negative 2.
Very good, awesome. So now negative 2 times x is negative 2x, but I have to change the sign before I write. Negative 2 times negative 2 is positive 4, but I have to change the sign before I write. So the function we started with, which is x squared minus 4x plus 3 over x minus 2, can be written as quotient. What is the quotient?
X minus 2.
Minus the remainder over the divisor. And you can say, okay, this is beautiful, but what did you accomplish? A lot. Here it is. Just the quotient, y equals x minus 2, will be the slant asymptote, not anything about the remainder. Nothing is wrong, don't cross it out. I'm just saying only the slant asymptote is only the quotient. So if I graph y equals x minus 2, how does it look like? Does it have a positive slope and looks like this? Or does it have a negative slope and looks like this? Which will be the shape of y equals x minus 2? Number 1 or number 2?
Number 1.
Number 1. Which means it's coming from negative infinity and going to positive infinity. That's what I have to copy for the end behavior. Because this is y equals x minus 2. And I write on the side, y equals x minus 2 slant asymptote. We are ready to graph. No, I will not ask you to graph these functions, but I will ask you to find the slant asymptote though. Just to find the slant asymptote. Okay, so let's graph this function. All I need is my table. I don't care for anything else. Nothing else matters here. So when I graph a function with asymptotes, what do I have to graph first?
The asymptote.
Thank you very much. So we have a vertical asymptote at 2. We have a couple of points that we can plot. 0, negative 3/2 is right here. 1, 0 is right here. And 3, 0, which is right here. 0, negative 3/2 is this point. 1, 0 is this point. 3, 0 is this point. I have to graph, before I start, I have to graph y equals x minus 2. We've done that a long time ago. How do I graph y equals x minus 2? I need 2 points. I need the x and y intercepts. I have to make x equals 0 and determine y. And then I have to make y equals 0 and determine x. When x is 0, I covered it. How much is y?
Negative 2.
Thank you. So 0, negative 2 is 1 point. In the next one, I cover y. And I have to bring negative 2 to the other side. So when y is 0 covered, then x equals?
No. 2.
Very good. Awesome. Very good. Thank you so much. 2, 0. So I'm plotting these points, 0, comma, -2, and 2, comma, 0. And here is the slant asymptote. Now I'm ready to go back to my table and do what the table is telling me to do. The table says, from approaching the asymptote, -infinity, cross the y-axis, the x-axis, and go to infinity on the left-hand side of the asymptote, vertical asymptote. No problem. One more time. Close to the slant asymptote, from -infinity, cross, go to infinity. From approaching -infinity, close to the asymptote, the slant asymptote, cross the y-axis, cross the x-axis, and go to infinity. On the other side, from approaching the vertical asymptote, -infinity, cross and go to infinity. This is the function x squared minus 4x plus 3 over x minus 2. I will not ask you to graph it. If you want to check with the graphing calculator, let's do that. Clear anything you have, and you have to put in two functions. You have to put in this function carefully with parentheses around the numerator and the denominator, and you have to put in this function because the calculator will not put it in for you, which is the slant asymptote. So I'll just go ahead and go to y2 and put x minus 2. And numerator parentheses, x squared minus 4x plus 3, close the parenthesis, divided by parentheses, x minus 2, and close. I see that the action happens more on the positive side and on the negative side of x. So I'm going to say -5, +5, -5, +5. Window. -5, 5 with a scale of 1. -5, 5 with a scale of 1. Let's see what happens. And I just click. I can go back and readjust. So here comes the first piece. Here comes the second piece. And now the slant asymptote. Again, maybe you can. I don't know how to make the calculator put in the vertical asymptote. That's exactly what we have here. I'm not asking you to graph these, but I will ask you to determine the slant asymptote. So a question, for example, for you would be something like, problem, well, let's say 86 on 427. Can you follow? Did I lose anybody? I hope not. Is this okay? Can you see? Hello, anyone? Okay, so x squared minus x plus 1 over x minus 1. I'm going to ask you what type is it? And you will say, this function is a rational function of type what? Careful, one more time.
Right.
Yes, very good. Awesome. I'm going to ask, does it have a horizontal asymptote?
No.
No. No horizontal asymptote. Does it have a slant asymptote?
Yes.
Yes. Slant asymptote, and then I'm going to say find it. How do I find the slant asymptote? What do I have to do?
Divide.
Divide and identify just the
Quotient.
just a quotient. That's all we need. Excellent. So x squared minus x plus 1 and x minus 1. So X times what is x squared?
X.
Yes, perfect. We go back. Can you see this color or not? Should I get rid of it?
It's going to be
Okay.
colored. Yeah, hold on.
So x times x is x squared, and then negative x squared, negative x, but plus x. I bring down the now 1, but I can continue. So the function f of x, x squared minus x plus 1 over x minus 1 equals the quotient, which is x, plus the remainder, 1 over x minus 1. So what is the slant asymptote then? Y equals?
X.
Thank you very much. Just the quotient. Final section of this chapter is about rational and polynomial and rational inequalities, how we solve those. We know how to solve, so 3.6, polynomial and rational inequalities. We know how to solve absolute value. Done. We know how to, yes, we know how to solve linear. Done. We know how to solve compound inequalities. Done. What we don't know is how to solve polynomial and rational. So we're going to work on polynomial first. So I hope you're going to find this the easiest possible section. Polynomial inequalities. An easy, simple one first. And that doesn't even involve factoring, just it's already factored for us. 31 on page 441. And we have x, 3 minus x, x minus 5, less than or equal to 0. And then we're going to look at one that we need to factor. But first, let's look at this one. Okay, what degree is this?
Two.
Degree 1 times degree 1 times degree 1.
Three.
Very good. Thank you. So I see 3 factors, and I'm not going to distribute. I'm not going to do anything. That's already factored. I'm happy for that. So let's use the following table. X is the variable in the problem. Variable in the inequality. It can be any real number. The next row, I will put the first factor I see. Okay, x. The next row, I put the second factor I see, but I will write it in descending order correctly. The next row will be the next factor, which is x minus 5. The very last row is what I'm interested in. I don't care for this, this, or this. I care for the product because I'm solving this product less than or equal to 0. So then we have x times negative x plus 3 times x minus 5. Okay, next step. Please tell me, when is this quantity 0? For what x value? And I'm going to write it here on the side. When x is?
0.
Perfect. When is this quantity 0? For x equals?
3.
Perfect. When is this quantity 0 for x equals? Very good, awesome. Great job. So I'm going to put these numbers in the correct order up here. And no other number is required. Since I know that x is 0 at 0, under 0 I will write 0. Since I know that negative x plus 3 is 0 when x is 3, I'm going to write 0 under 3. Since I know that x minus 5 is 0 under 5, I'm going to put 0 under 5. Under each of these numbers, I want to see what happens to the product, because I want the product. That's what I want. So when the first factor is 0, what will the product equal to? And I'll put it here.
0.
Thank you very much. When the second factor is 0, what will be the product? What will the product equal to?
0.
0.
Thank you very much. Make sure you put it exactly under 3. And the same thing for number 5. X equals 5. What will happen to the product if the third factor is 0?
0.
Excellent. So now we go back to graphing linear functions. Let's just think. If I graph this, do I graph it like this, from negative to positive, or I graph it like this, from positive to negative?
Negative or positive?
Very good. Excellent. Now I look at this one. It's a linear function. Same question. Do I graph it like this, from negative to positive, or I graph it like this, from positive to negative?
Negative to positive.
They cannot be the same.
Positive to negative.
Right. Is that clear? Because they cannot be the same. The one with positive slope goes from negative to positive, but the one, that's why I put them in correct order, in descending order. So I can realize that this one goes from positive to negative. You don't have to do this. You can just plug a number. Pick a number, plug it in, and you'll see if that's easier for you. Finally, this one, does it go again from positive to negative, or from negative to positive, or from positive to negative? This one.
Negative to positive.
Excellent. I still haven't fully explained what I'm doing, why I'm doing this, but I will in a second and you'll understand what happens. See, this is a product. Here in the table I see 1, 2, 3, 4 subintervals. Let's analyze what happens on the first subinterval. I see 2 negative signs. The positive, I don't even care. I see 2 negative signs and I multiply them. What is the sign of the outcome?
Positive.
Excellent. Okay, now in the second subinterval, I see 1 negative and I have to multiply. I multiply x, I multiply by negative x plus 3 and by x minus 5. The first one is positive, the second one is positive, the third one is negative. So what is the sign of the outcome?
Negative.
Excellent. In the second subinterval, what do I have? I'm multiplying 2 negatives. The positive don't even look at. The positive will not have a, very good. The positive will never have an impact on anything. And the last one, I see a negative. So what is the sign of the last one?
Negative.
Excellent. Stay with me. What am I asked to solve? I'm asked to find x such that this product is less than 0. What sign is less than 0?
0.
What sign?
Oh.
What sign will be less than 0?
Negative.
Yes, only negative will be less than 0, so I'm looking for negatives. But this is where the product is negative, but I want x, which means if I pick x between 0 and 3 or between 5 and infinity, the product will always be negative, as it should be, because I want less than or equal to 0. So the product is ever negative? Yes. When x is 0 between 0 and 3, and when x is between 5 and infinity. So I write the solution. X in the interval. Because I have the equal symbol, I have to use brackets. 0, 3, union 5, infinity. The second example will be even better. This was just the first. Okay, so let's look at 24. This time, let me look and see how I am with the time here for the videos.